Welcome to Penrose Learning, where we make understanding easy.
You start by sizing the problem, check RAM and disk, then pick an initial chunk size that fits. Use streaming reads with Pandas, read CSV chunk size equals, or initialize Dask or Apparel datasets to avoid loading everything. Profile a small representative sample, 1 to 5%, to detect schema drift, nulls, and outliers. Once done, lock down column D types and parsing rules so subsequent reads are consistent, and make sure to log the sample findings for reproducibility and later validation. You now implement the pipeline. Read in manageable chunks, apply vectorized transformations, and avoid Python-level loops. If needed, accelerate hot functions with Numba. Use incremental reducers or Dasks map/reduce to compute aggregates without materializing all rows. Persist intermediate outputs as parquet with snappy compression to speed later stages, and prune columns early to reduce I/O. Once done, monitor throughput and memory per worker, and make sure to checkpoint state, so failed jobs can resume without reprocessing everything. You finish by merging aggregates and performing final joins using indexed keys to avoid full shuffles. Write compact output files in Parquet or Feather for downstream use. Run validation. Compare totals, row counts, and sample checksums against the original sample to catch subtle errors. Once done, run a full end-to-end test on a subset, and then scale. If things go wrong, increase chunk size slightly, add workers, or profile with trace malloc to find memory leaks, and make sure to retry from the last checkpoint.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.